Stream started? Alright, cool. Stream has started. How's everyone doing? Let's see. I've never done this before. But, cool. I'm ready to get started. There is a little bit of delay between this. It seems like there's a little bit of delay between the stream and, real time. So if anyone sends messages in the chat, I'll get them just a few seconds later. But anyway, all right. So I prepared a couple issues to work on. One was from the Java SDK. There's the BigQuery sync. It has a feature request where people want to be able to control how it spills to files, and this is the issue. And so I was planning to do this initially, but then after looking at it, it seems like it's a single line change, so we'll do this at the end. And so the one I'm going to work on now is this other one, which is also the BigQuery sync, but this one is for the Python SDK. And can everyone hear me okay? Let's see. Here, okay. Anyway, so yes, and so basically what happens here is that in the Python SDK, when we write to BigQuery, we let me there's a transform code to BigQuery. Let's go to the definition of it, and it's a bit of a complex transform, but basically it has two different methods that we can use to write to BigQuery. Here's the method. There's the method expand, which expands the transform. Here we determine which method to use. We're not going to look too much into how we determine the method, but there's basically two methods. There's the streaming inserts method, and there's the file loads method, which is, I guess, it's the other method. So here in these few lines, this is the transform that we have for when we do streaming inserts, and this is the transform that we have when we do file loads. Anyway, and so for streaming inserts, basically we get our input p collection here, and we pass it to a Pardue that appends destinations to it, and then so we'll get, so we can look at it. It's in BigQuery tools. All it does is it takes a function that generates a destination depending on the element, and so it outputs pairs of destination comma element. So, in this case, the destination is a BigQuery table. Anyway, so it creates those key value pairs of destination and element, and then it passes them down to this function called BigQuery write function, which what it does is it basically batches a few elements and writes them to BigQuery as a streaming insert. And so the bug is that in the process method for this function, we obtain destination, and then we decide whether we want to create this destination table. And the way in which we determine whether to create this destination table is here. We keep a set of tables that we have observed. And so if this table has already been observed, then we don't create it again. But if it has not been observed, then we try to create it. Now this, and then we add it to the observed tables. And so this looks like it makes sense, but for a streaming pipeline, there's a lot of bundles. So we're going to do this check a lot of times. and we'll end up trying to create a table a bunch of times. And so users are seeing problems where where the BigQuery quota for table creation is getting overwhelmed. And yeah, so that's the problem, right? Their pipelines become slow. So let's clone the code for Beam. BigQuery Python fix. Right. And from the stream, but anyway. All right, and we clone the code, py fix, and then we go to the Python section. And so to work on Python code for Beam, we use virtualenv. We create virtual environments to have a separate environment of Python where we can develop whatever we want and have different versions for each package. I'm lately developing Python 3.5, so I'm going to create a virtualenv with Python 3.5, and then we're going to activate. And activate. And now we check which is my Python binary. It's in this subdirectory. Pip, same thing. And so now, I have my Python installation, my part in virtual environment. So now I'm going to install Beam, right? And so to install Beam, we do this -egcq test. And what this line's a little confusing, but what it does is it installs the current, the project in the current directory for development. So whenever I make changes to the source code, I can run them immediately without having to reinstall. So anyway, we go ahead and do that. And while we wait for that, we can open IntelliJ. Open IntelliJ. Oh, someone told me something. One sec. Okay. I've been told that the terminal is blocked by myself, and I have to speak up. All right, one sec. All right, I'm gonna try to speak up now. All right, so we opened IntelliJ, and what we're gonna do here is we're gonna create a new project. It's a Python project, and for the SDK of this project, we're gonna use the virtual environment that we just created. So we're gonna say existing environment. And so let me find. All right, codes / bqpyfix as the case Python. All right, that's the directory that I wanna. Oh no, but we're selecting the Python installation. So we find the virtual environment. Where's the virtual environment? Oh no, the virtual environment is the case Python. Here, vemb. And then within this vemb, we find the Python binary, which is what we want IntelliJ to use when it runs our tests, right? Right? We do that, and then we say next, and then we tell it where our code is, right? And same thing, codes, and then BigQuery pyfix, SDKs, Python, right? Let's just call it BigQuery quota fix. All right, here we go. Okay, cool. And so now IntelliJ is importing the project. Let's see. We have here our Python project. It's loading. Over here, the virtual environment has been installed. Beam has been installed into the virtual environment. So now I can find the actual file where this where the problem is. It takes a while because it's indexing. Query. Here it is. Right. Okay. Write to BigQuery. Right. Can we? Here it is. So this is the write to BigQuery function that we had seen before. And here's the path where we wanted to avoid trying to create the table so many times, right? And so the reason, again, that we're creating the table so many times is that we're here in this BigQuery write fun. For every time we call process, we're populating a set of observed tables. So this means for every bundle, this set is empty, and for every bundle we try to recreate the table, right? And so if we want information that we want to keep across bundles, we can do that with something called a stateful do-fun. And so what a stateful do-fun does is it keeps state across bundles for the same key. And in fact, we already have this append destinations function that adds that creates a key value pair of destination and element, right? So basically all we want to do is add another transform, beam pardo, with a new special do-fun that I'm going to call, let's say, create table if necessary fun, right? Cool. And so this is a do-fun that we're going to code for Beam, and it's going to be a stateful do-fun that, if necessary, is going to create the table. Right? And so let's find a good place in the file to create it. Let's just do it over here. Class create table if Beam. And so this is a do-fun typed class, right? Cool. This is the inputs that it receives, the element. All right. So here's our do-fun, right? So this do-fun is going to run before this other do-fun that we have right here, which is actually, let me show in the window the structure of the file so that you can follow a little better. Cool. All right, so we're here in BigQuery write fun. This is the first the do-fun that we had originally, and within it there's this function, create table if needed, right? And so basically what we're going to do is we're going to lift the logic from this function and move it to our new function. And it also needs, by the way, the schema information in case it's going to create the table. So let's see, what does this look like? We're going to just completely lift this function out. We're going to go down to our new function, create table if necessary. Maybe just here for now. Cool. Now we go back. to our BigQuery write fun, we're no longer going to need the observed tables parameters. So the decision of whether to create the table or not is going to happen somewhere else. And then our process method is also going to take in a side inputs, right? And specifically, let's see. Oh, self schema. All right. Yeah. So self schema is also going to come. It's going to come out and going to come with us. Right. Cool. So basically, we're going to remove this from here. We do need. Right. So we're going to remove all of this from here. We're going to move this logic to our new function. So process. Right. I got told to speak up again. Let's see. How do I do this? Maybe I need to tell my microphone to be a little louder. 1 sec. All right. Excellent. Now I don't have to speak up. Now I can I can rely on my computer to speak up for me. All right. Let me tell the person that's helping me. All right. Cool. And so now we're back to where we were. So destination. Remember, the elements that are coming in are key value pairs. So this is going to be the key from this key value pair, which also means that the row is element 1. By the way, just so you're aware. Cool. And then where does this schema thing come from? It's going to come from the constructor init self schema.
Hello.
For me?
Also, I don't know what you like that Eric said about
Alright, then.
mac and cheese.
Schema. Sorry, I'm in the office, so it's a little hectic. Right.
Wow, this is awesome.
Schema side inputs. Alright. So we have all of the inputs that we need. Sorry guys. This is what it's like in a crowded office in downtown Seattle. But anyway, okay, cool. So we have our new function. It receives a schema, which the schema can be a static value, a function, or a value provider here. And then it calls create table if needed, where we pass a table reference. So we're going to use parse table reference. Okay, and it takes in a schema. Alright, cool. Alright. Okay, and then it has the same thing where we check the observed tables, except we're going to do something special in a minute, where we're going to use user state, as I had said before. But first, we're going to go back to our to our BigQuery write fun, which is the function that told the data to BigQuery. Okay, and we're gonna, let's see. We've removed all of this, so we're not gonna need the schema side inputs. And we're not gonna need this schema argument. So we also remove it from the PyDoc. We also need these things such as create disposition and write disposition. Okay, so we're going to take this out as well. Okay. So schema and create disposition, we're going to lift them out to our new function. Let's see. Init. We also have create disposition. And our PyDoc. Right. Is everyone with me now? Let's see. Let me check on the live chat. Oh, I'm. Oh, thank you guys. All right then. Let's see. All right. So we have our input create disposition. So we're also gonna save that. Disposition equals create disposition. So that way, if create disposition is set to never, we just never create the table that we're considering. And now there's one more thing that we have to do. This is the big step. We're gonna add a state. And so, what is state? State is a thing of stateful beam, right? Stateful processing with Apache Beam. So there's a very good blog post written by Ken, where he goes over what does it mean to have state in a streaming pipeline, and there's some Python examples where we look at we see how we can create state for our pipeline that will last through multiple bundles, and so we have that here. It's all good. We want to specifically use a kind of state called bag state. So for state we define as a class attribute, we define a spec for the kind of state that we want to store, a name and a coder, right? So in this case, we're just going to store whether or not we have created the table already. And so we're going to create created already state, right? And we're going to bag state spec. Table created already, and we're gonna find a coder that is appropriate for this. So let's look at coders. There's variant coder. Let's look at what other coders we have that may apply. In this case, we just want a boolean basically that says that whether we have created the table or not. We have bytes coder, var_int coder. Maybe we'll use var_int coder. Now, a problem here is that IntelliJ does not automatically import these unknown references, so we have to import it ourselves. So we have var_int coder and bag state spec. So we go to the imports Alright, Apache Beam transforms. Okay, from Apache Beam transforms user state import bag state spec. That's one. And coders. Oh, we have coders already imported, so we can just say coders dot variant coder. Cool. All right then. And so we've created the spec for this state. Now how do we tell our process call that we're going to pass a state typed argument? We use this thing, maybe a little bit confusing, but basically we're saying there's going to be, in this argument, there's going to be a state parameter that is going to contain this state specification. All right, so we're going to do, right, let's see, is this loud enough now? Anyway, cool. So we have the element, now the side inputs that we're going to take, and now we add table created already equals beam do fun state param, and then we just say created already state, right? So we're telling Beam that we want a way to access state in this argument, okay? And so, okay. Now, let me think about what we want this function to do, right? We want this function to receive a key-value pair, if necessary create the table, and then pass that key-value pair to the next function that will actually write it to BigQuery, right? So, so in that case, if we can before doing any special computations, we can just check if we don't need to create the table at all. Okay, so we go and we say if our create disposition is to create never, we just move on, right? Oh, by the way, we're just gonna yield the element out. We're gonna do that at the end. I guess if we alright, so if we don't want to create never, cool. Okay, so here we put the actual, we're going to pull the actual creation logic, and then in the end we're gonna yield the actual element downstream so that it's written to BigQuery, right? Okay, cool. So if we are willing to at some point create the table, then we're going to do the this stuff. Okay, so first we try to get the schema for the table that we might create, and then we call to create it, right? Now we don't need this special observed tables because we're not going to use that logic anymore to create the table. There's this thing that we have to migrate from the previous function. In fact, it really seems like we don't need a whole helper function. Let's move all of this to this thing. Also means okay. Alright, let's see what people are saying. Not much. Okay. Cool. We also do table reference. BigQuery tools, parse, table reference, destination. Okay. Right. Now we let the world know, we log that we're going to try to create a table. Let's see. Do we need to check the right disposition? Oh yes, because that is something that we need to tell the table when we create it. So I'm just gonna Okay. Cool. Alright, so now is where we do the tricky thing where we retrieve state, right? So let's see how the block code says we're supposed to retrieve state. We have previous prediction state. We do we can do read, and then if so we read our bag state, and if it contains anything, then we don't have to do anything else. We exit, right? So let's rename this to table created state. Right, and so okay. If we're willing to create and table create a state read, so in this case this will return an empty list or not. So if we're willing to create the table, and there we have not created it, then we actually go and create it. And so we do the table creation, and then we just add, whatever, true. Oh, we said variant, right? So we add just a single element, 1. Cool. So I think that's all we need to do. So if our create disposition is not never, so if we're willing to create a table and we have not created it, then we retrieve the schema, we prepare everything, and we create the table. And so now this can actually go in a helper function. Create table. Okay? And to create the table, we receive table reference and a table schema. Everything else comes from the actually we don't even need all of that, because so we just do the destination. Right. Oh, and the schema side inputs. Okay. And so we call self create table with the destination and the schema side inputs. Right. Cool. So this is all we need. So in this if, we create the table. Once we create it, after this, we mark it as having been created, and then, yeah, we don't need to create anymore. Now we're just missing any other parameter that we need to receive to create in the constructor. There is this self additional BigQuery parameters. So let's add that. And let's go back to our old function to lift all of that information from the PyDoc of the old function. Okay. Cool. Okay. By the way, we seem to need a KMS key as well, so remove this. And we're going to go back down to our new function and add all of this to the PyDoc of this function. Everything okay so far? Let's see. Cool. Okay, so we have right disposition. We have a test client, which is an override of the BigQuery client. We use it for testing, so we're gonna want that as well. And we have the additional BigQuery parameters. Let's indent this nicely. Okay. Okay, we'll indent this as well. We indent this as well, and we unindent this. Cool. And so, I guess the PyDoc for this function, do we write PyDoc usually? Right, so we just say initialize, and then the actual thing happens over here. Cool. Now we don't need the KMS key. We don't need the create disposition here, or the write disposition either. We don't need the additional BigQuery parameters. But we do want to have them later as display data, so we lift some of this display data. Right. We add the display data to the we add KMS key, test client, additional BigQuery parameters. Okay, cool. Okay. here we're going to take. Oh man, we're gonna end up just coding. I'm gonna try to hurry up to KMS key. So we're calling it BigQuery client. BigQuery wrapper equals let me copy that from BigQuery parameters. Okay, and let me just copy whatever we do for the BigQuery client. No, test client. Then we create a wrapper here. And we start the bundle. Here. Okay, so we're going to do the same thing here. But instead of creating it when we start the bundle, we just need to create it when we actually want to create the table, right? So client, command directly. Cool. All right. You might note that we're not doing anything with KMS key. It's important. So figure out what to do with this. Okay. So I think we've coded pretty much all the functions. Let's just say function. That's one. And then finally, step for do from dot BigQuery tables if necessary. Cool. All right. So this is the sketch of what the function should look like. Now we go back to our write to BigQuery transform, specifically to the expand, and we replace it, right? So we create table if necessary fun. We want to look at the documentation here, so let's do the parameters that we need. This is this is poorly indented, but 1, 2, 3. Okay, so we use 4 spaces for indentation. Schema equals self.schema, comma. Oh my god, why are you doing this? It might be a syntax problem. No, this is, as it turns out, not my fault. Okay, so we're gonna do this. You guys can see me being this done. Right. Create this position. Self create this position. Write this position. Self write this position. What else? What else is there? KMS key. Test client and additional parameters, right? KMS key. Self KMS key, test client, self test client, additional core parameters, self additional core parameters. Cool. That's one thing, but it also needs to take inside inputs, right? And so we take this side inputs that we're passing here. We don't need them anymore. And we pass them over. Oh no, my bad. We take them from here, schema side inputs, and we pass them over here. God, the indentation. This indentation's gonna kill me. All right. Someone texted me. I got a question. When am I gonna do the Java bug? I am planning to do that. I mean, I guess after I finish this, but I'll go a little over time and show how I do the other bug. The other bug is much simpler. But anyway, go for a few minutes. All right, cool. Okay. So this almost certainly has bugs, right? And so, how can we test when this thing has bugs? Okay, well, glad you ask. Great test. That's why we have the test client, where the client that we use is a mock, and so let me try to write a unit test for this function, where we want to say that we only create a table once. Ooh, but okay, we're gonna have to see. But all right, def test create table only once, and so let's see if we have any other test pipeline. Right, so we don't have any best practices for testing pipelines in this file. We do have a little bit here. Okay, so we're gonna do with Beam test Beam pipeline. So we're gonna write a normal test with a pipeline that will run on the direct runner, and we're gonna pass a test client. But so first, beam dot create, or in fact, you know what? We need to do this with test stream. Test stream is a utility that we have in Beam to test the behavior of transforms with input streams. Let's so we're gonna define a stream that has a few events. First, we're gonna set processing time, advanced watermark. First, we're gonna set the watermark to 0, and then we're gonna pass some elements to this transform, right? And so we're gonna have table 1 table. This is our first element in this bundle. And 2, okay? So here we're passing 2 elements, and we're letting the pipeline run, and then afterwards we're going to advance the watermark to 10 timestamp 10, and we're going to add new elements. Same table. Let's call it element 3. Table element 4. Okay, and this is the input to our pipeline. So we're going to do p dot test stream, and then we're going to pass it to BigQuery dot create. What is the name of the transform variable? Create table if necessary from Beam Pardue create BigQuery, create table if necessary, fun, right? And we look at documentation. Is it able to find it? Oh, it's not able to find it because it's not exported by the package. Oh my god, I got scared by a calendar notification. How do we test? I forgot how we test transforms that are not exposed. We should be able to. We should be able to test them. Let's see. Let me try from Apache Beam IO GCP BigQuery import. Will it let us? Oh yeah, it is letting us. Okay. So I need to clean up this code, but I'm trying to speed up how we do this. Any schema. Doesn't matter what we pass to it. We're only testing position. And now create this position can be anything as long as it's not create never. Actually, we need to have sensible defaults here. So we're gonna make the KMS key be none. So this stuff we're gonna make it be none. And then the main thing is that we need to pass a test client. Now let's see how we're doing it in other tests here. So we're doing client walk. When we do get table, right. Create. Okay, so I can't find an example where we tell the client what to do. People try to create a table with it. Let's try something like this. Let's call it client. Alright. Cool. And so basically we're passing a set of key value pairs. Let's call it output by the way. Okay, so we have that. Yeah, so we're passing a set of key value pairs in two different moments, and we want to make sure that the table is only created once. So we're going to do some sort of assertion where we say, oh man, so we'll do something like assert true. This has to be outside of the pipeline. So after the pipeline is done running, we do this assertion, and we say client. And so now we need to go and look at the implementation and see how query wrapper. And we go in here. It's a bit of a complicated function, but here we have a create table. Client tables insert. Okay, so we have to do something like client tables insert called. And I want to say that we called it only once. I wish there was a very easy way to do it, but there isn't, so I'm gonna have to look it up. Whoops. Python mock call count. Right. Count. Call count. Okay. Okay, so we can use call count. So we do assert equal call count. And we want to assert that it only was called once. Now, this is almost certainly not going to work, but we get to take a chance and run the test. Right. The first complaint is that Apache Beam has no attribute doFun. So let's see how we're defining the doFuns here. I'm just importing 20. Here it is. Let's try to run it again. Another one. This. Yes. Let's do this again. Okay. So we did reach a point where we get a result, and for some reason the function was not called. Okay. So let's since we're on time and I wanted to quickly do the Java example, I'm just gonna do some logging here. Table, create the read. Read. And after adding, table created read. Now let's look at what happens when we log that. Table create. We didn't get login information. Oh, well, that's annoying. Let's see. You know what? Why that may be? That might be because our streaming tests they're a little bit troublesome. So we're going to create some pipeline options. I think we can pass our fee. Streaming. Let's see if that'll help us. This is a bit of a trick, and I'm sorry that I'm going with that trick for now, but that's odd. Alright, well, I think I'm not going to be able to get to the bottom of that for now. But yeah, so this is an example of developing a fix for Beam. We have unit tests. You can import your code into Python, and you can debug it, which is nice. Let me try. No, I think I should leave this, and I should do the Java one. All right, the Java one is way quick. The problem with Java is basically that a Beam user requested access to a function that is only visible for testing. So all we need to do is import, make that function public. I'm not just going to do it, because I want to. This has to go through code review, and we certainly want to be cautious of when we make more functions public. But in this case, we're just going to. I think it makes sense. Was it import? How do we do this? New project. Let's do new project from existing sources. Now I cheated for this because the Java build takes quite a bit. So I pre-downloaded and built the Java, the Beam SDK and the Java thing. And so we open IntelliJ in a new window and we tell it to import. Now, because the Beam Java codebase is huge, this is going to take a while. And so while that happens, these modules don't get parsed. But currently, just basically Gradle is importing, Gradle and IntelliJ are importing all the code for Beam, all the different modules and packages, etc. But because we smart, we know that we want to make a change in BigQuery IO. We go straight to the file, and with max files per bundle, this is the function that we want to edit. Let's see. That's right, max files per bundle. Whoops. So all we want to do with max files per bundle is make it public. It's not rocket science. Public. Cool. Right. Make this public. And now we look at Git, the console. We can see the change. And so we use Gradle to build, and so SDKs, Java, IO, Google Cloud Platform. I'm using Gradle to first check the formatting of my change. It's a tiny change, so the formatting I think is going to be okay. We use Spotless to do formatting. It's pretty nice. It does auto formatting of your code and then does checking. So we run Spotless check. Spotless doesn't complain because the change is so small. And then we just run Gradle check. So what that does is it runs a series of tests on change. Basically runs the unit tests. And so this change I did try yesterday, and this takes like 10 minutes to actually do all of the tests. All we want to do here is, supposing that the tests pass, I'm pretty sure they will. Every engineer has said that. And then the tests fail. But let's just create a pull request. Let's do git remote add my remote GitHub. So I add my remote repository, and I create a branch, public max files per bundle. So I'm in a new branch. I just add my change, git add per user request, making max files per bundle public. Okay, now we push to my remote to this branch. And that helps us push our changes to GitHub, which we look at my fork of Beam. Wait a little bit until we get a notification. Okay, we can find the branch. Here's the branch. And we can create a pull request. This is the Jira issue, so we tag the pull request with this Jira issue, so that work can be tracked properly. And then we create the pull request. And so I'm hopeful that the tests are going to pass. They seem to be doing okay so far. So if the tests pass, what we do in Beam is we basically assign a reviewer. I'm going to ask Ruben to do this review. So I tag him. Oh no. A test already failed. But I'm pretty sure it didn't fail because of what I did. Because tests have been flaky in Beam. So all you do is you rerun the test. And if it does fail again, then we go and check why it failed. But anyway, so yes, this is one, the process of making a change in the Python SDK. And two, the process of making a change in Java and making a pull request. So I hope this was useful for someone. Yeah, and that's it from me. I think I'm going to wrap it up now. But yeah, thanks for those who tuned in, and feel free to send any questions. And, yeah, hopefully I'll open the pull request with the Python change soon. Because I did everything very fast, I'm probably going to have to make adjustments. But anyway, all right, thank you very much. Bye-bye.